Hi everyone, and welcome to today's webcast, the Lakehouse What, Why, How. My name is Maria Pinilla, and I will be joined today by Al, a colleague of mine. We're both business intelligence and analytics consultants here at Thorogood, and we will be walking you through today the Lakehouse. If you have any questions, our contact details are here on the screen. So before we go into the details of today's event, we wanted to start with the introductions and then introducing the Lakehouse, the recent history, as well as delving a bit deeper into what is currently out there in the market with regards to vendor landscapes to bring the Lakehouse into a reality. And then we will show a quick demo on how actually you can make this Lakehouse architectural pattern work in your organization to close with some considerations. So having done the introductions to both Al and myself, as well as our company, I would like to now introduce the concept of the Lakehouse. So when we talk about Lakehouses, we're talking about more than data management. So in order to fully understand what a Lakehouse is and why it is actually revolutionary to those who adopt it, it is useful to first have a look at the recent history in modern data management. So for that, we need to start with the data warehouse, a concept that has existed since around the 1980s, when it was developed to mainly help transition data from power and operations to fueling decision support. And technically, a data warehouse is just an analytical database that would sit on top of transactional data stores and acts as your organization's single source of truth. As we said, traditionally serving use cases that require aggregated transactional data. And we often refer to reporting on a data warehouse as traditional business intelligence or BI. And given the rapid availability and application of async transactions and the scheme-enforced data structure of the data warehouse, it is well known for its enforced good data governance and helps keeping the data in line as well. Another thing to highlight about data warehouses is that they often make use of familiar query languages, which benefits the widest group of analysts who can actually make use of the skills that they already have. But this also helps connectivity to other tools and that use these common query languages such as SQL, so that it makes it easy for the tools, as we say, to interoperate. And more recently, data warehouses have also been made available as cloud versions with the added benefits that brings about. So especially lowering the cost, complexity, and time to value that have traditionally inhibited the adoption and successful use of data warehousing technology. However, as the volume of data available and especially data formats generated have been growing, we've seen a real increase in the use of cheaper and very different approaches to store all sorts of data. And with this, I will refer to more specifically data lakes. So a data lake is similar to a data warehouse in that it is a central storage repository, but it can hold all kinds of data. So that being structured, semi-structured, or unstructured data. And this is due to a principle called schema on read, meaning that contrary to the warehouse, there is actually no predefined schema into which data needs to be fitted before it being stored. It is only when the data is read that actually it is parsed and adapted into a schema as appropriate. But another of the attractive features of the data lake is that they are usually configured on a cluster of inexpensive and scalable hardware. So that means that data can be ingested into the lake, ready for any data, and then it's only, well, you don't really need to worry about storage capacity. So you can really see the attraction of this approach, right? So since it is actually cheap to store large volumes of data, you can store everything. By using open formats that are shared across different technical platforms, it is actually possible to connect to the data with a wide variety of tools, and you can perform on your data everything from large-scale data processing to advanced analytics. So in this regard, there are a lot of capabilities of a data lake that provide a big step up versus a data warehouse, but yet that has created somewhat of a performance and data management challenge in other ways for traditional BI. Because the data lake, even though it's, as we say, like a huge step up with regards to the data warehouse, it still lacks several critical features. For example, they do not support transactions and they do not enforce data quality. So the advantages of data warehouses, if we want to compare them, were built up through intentional software design decisions, whereas the data lake functionality really happened to support an explosion, if we want to call it like that, in data technology. And as such, the former is, as we said, more rigid, more structured, with mature data governance, application and user access that enables repetition, whereas the data lake is more flexible, unstructured, and most importantly, requires better knowledge of the various data types and their relationships. So then it should come actually as no surprise that many organizations have a data ecosystem consisting of both a data lake and a data warehouse. The data lake would serve as the data landing zone and source of truth, while the data warehouse is used for use cases such as BI. However, this architecture can require complex pipelines to move data in between the lake and the warehouse layers. And usually this leads to more of a lag in between data landing in the lake to then being copied into the warehouse. And with this comes the extra cost of making of any extra dataset request, for example, a drag, because such changes would require additional data engineering work or leading to copies of data and a data governance and security mess overall. Now is where the data lakehouse comes. So the data lakehouse is nothing but a unified approach for all your data use cases from BI to AI. So through a data lakehouse architectural pattern, we actually choose the properties of a warehouse and the properties of the lake that are the most valuable, because it is a unified data architecture that implements warehousing functionality over open data lake formats. So all in all, it keeps the benefits of cheaply storing large quantities of both structured and unstructured data, plus makes this suitable for use in complex analysis for BI purposes. And we can take advantage of the ability to process all manners of data sources, data types, and data volumes, while relying on the schema enforcement and transaction support of the warehouse to provide overall the data that we expect for use cases. And this approach also lays out a couple of principles that help to keep maximum flexibility, such as using open formats that allow other tools to connect to the data, support wider groups of users, and more diverse workloads, all in the same single trusted copy of the data. However, we cannot talk about the data lakehouse without talking about Delta Lakes and Databricks, which we'll be going into a bit more of detail in the subsequent slides. But before, we wanted to actually talk about, what are the added benefits of adopting this approach to your data management and storage. So overall, we can classify this new data management architecture, that radically simplifies enterprise infrastructure and overall accelerates innovation into three main, as we say, like benefit buckets, them being efficiency, flexibility, and governance and security. And if we think about the how the data lakehouse enables this for efficiency, we can directly say that it is actually quite cost effective. So it is cost effective to restore structured and unstructured data at the same time that it gives direct access data for any tool analysis with less time and effort in administrating that data. It has enhanced governance. It eliminates that we were saying before, that multiple data copies, which mitigates data drift at the same time, decreases latency, and requires less supportability. And it also allows to separate duties across the data pipeline stack and increases the reproducibility of the work. And when we talk about flexibility, some of it comes from the cloud offering in itself, but it is quite useful in realizing automation, then making it quite suitable for MLOps, CI/CD, and analytics use cases. It makes data analysts and data scientists more self-sufficient, also leading to faster time to insight, and overall contributes to businesses being more data-driven. And as we said, by taking the best components of the data lake and the data warehouse, we can get a better governance and security structure. So as we said, we couldn't talk about the data lakehouse without actually talking about data lake and Databricks. So let me just take 1 minute to talk about Databricks in the first place. So Databricks was founded by the same team that created Spark, and they themselves refer to the company as, or the solution as, the unified analytics platform. And especially that means that it caters to a variety of workloads such as data engineering, science within the same platform on one same underlying set of data. And it can run on multiple cloud providers and integrates quite well with the native cloud storage. So all in all, what it does is it adds strong data processing capabilities on top of the cloud optimized storage offered by the platform of choice. But in the context of the Lakehouse, the Delta Lake engine used by Databricks on top of your data lake would act as a structured transactional layer. And doing that allows companies to overcome a lot of the challenges that data lakes have had historically, or that have presented through the lack of ASIN transactions. So with Delta Lake, you can actually have access to this ASIN transactions, indexing, fine-grained control, as well as schema validation, among others. And by replacing data silos with a single home for structured, semi-structured, and unstructured data, Delta Lake is actually the foundation of a cost-effective, flexible, and scalable lakehouse. However, on top of that, we would need a high-performance query engine that would allow us to query and then can deliver the performance required for any traditional analytic workloads as well. And for that, I'm going to pass now the mic to my colleague Al, who would go into the different offerings in the market with regards to vendor landscapes and lakehouse architectures.
So let's get a little bit more technical now. We'll start off by looking at some of the vendor landscapes that cater for data lakes. And if you're familiar with some of the design patterns, hopefully what you'll see is it's not terribly different. Really, the fundamental underpinning part is within the data lake, we're structuring the data slightly different, so slightly different formats. We've typically found that Parquet as a file format in the data lake is a good optimal structure. And so Delta builds on top of that, as Maria mentioned earlier. Delta really is a layer on top of Parquet. So the file format is very similar, just with slightly different processing. Here we're seeing an Azure, a common, typical, kind of high level really, Azure architecture with data flowing on the left, with the reporting on the right. In from the left, in from various data sources, the data landing in a bronze layer, in a raw format, and then having processing as it flows through the data lake into the gold and silver layers. And in Azure landscape, really, there are two possibilities for curating and preparing the Delta Lake files in the Lakehouse, and that's either Databricks or Synapse. And we'll show you a little bit of that when we come to do a demo in a minute. And then the second, I think, fairly fundamental change here, and we'll talk about this a bit more in a subsequent slide, is being able to query the data directly from the data lake. You have options. You can query Databricks, you can query data in a SQL database, or you can have pass-through, or you could just query the data directly on the data lake. So with different options then, and that's something that will evolve as the vendor landscapes change. Just to switch that to AWS, switch back, switch forward, really not terribly different. And that's a good thing. It means that we're getting to some pretty common patterns. As things evolve, who knows where it will go, but right now, pretty common patterns. With AWS, some of the boxes changed for the more AWS native components. For example, EMR being the tool that employs Spark to read and manage the Delta Lake files, the Lakehouse files. And if I switch that to GCP, again, very similar design patterns. In this case, it's Databricks running the Spark engine, but very similar design patterns, which means that if you use something like Databricks, then you have an advantage if you need to switch or you've got multiple cloud architecture landscapes. Let's switch now to showing a bit of a demo. I'm going to switch across to Databricks. Here I've got Databricks running on AWS. And what we've got here is a Databricks notebook. Databricks is an entirely code-driven language to read, curate data and write back into a data lake, or indeed read from a multitude of sources and write into a multitude of sources. But here we're reading and writing directly to a data lake. Within the Databricks environment, Delta is now default. So when you're reading and writing data sets, it will try and use Delta by default where it can, obviously. And so what I've done here in order to do a bit of a demo, is I've set a couple of properties that disable Delta as a default. So now I've got to specifically say, I want to save as Delta, rather than that being a default. So what are we doing here? We're going to read from a data set. It's actually a data set of Amazon information, about 4,000 records. And this is a shared data set in Databricks. So you could do this sort of demo yourself quite easily. So I'm reading from a shared data set, and I'm going to write that as a Parquet format and as a Delta format. So I'm writing the data out from a shared data set to create my own specific data sets. That way I'm not going to break the original data set. So that's what I've done here in this first command cell. In the second command cell here, I'm going to create two tables so that we can use SQL. So up here, we did a little bit of Parquet, shows you, a little bit of Python, shows you what Python does to a small extent. And here we're going to reuse SQL. I'm doing that because most analysts, most developers are familiar with SQL. Personally, I've converted myself to Python. I like Python, but many people are still very familiar with SQL. So you can use either. So here, what we're going to do is we're going to create two tables, one that's not using Delta and one that is using Delta, just so that we can bring out some of the different features. So having created those two tables, let's query the not Delta table, and then we'll query the Delta table. I'm just going to do something simple and look at the list of brands. I've got over 1,000 brands, but a list of brands. We can see the first 7 brands from the not Delta table, the Parquet table, and we've got the same data set from the Delta table. And the first 7 records, they're the same. Great. We expected that. We've got the same starting point. Coming down my notebook, we're going to try to delete from the not Delta, the Parquet table. So we're going to try to delete a brand, and we're not in Delta, so we can't do that. That was one of the features of data lakes previously. So without Delta, without the Lakehouse, you weren't easily able to, or you weren't at all able to, no, I'll say you weren't easily able to delete records or update records. You could do it by several steps. It would take several steps. Read a data set, filter out the records you don't want, read in new data if you wanted to update, and then you could write your data set out. So it would take several steps to manage that data. Now, if I do the same thing using Delta, so delete from my Delta table, you can perhaps see some of the commands are slightly different, and it's deleted a number of rows. I've only got one row that's affected, but it's deleted that record. So Delta gives us some capabilities and makes life a lot easier in the way that we would typically have done within a data warehouse very easily. And this is the line that you would have written in that data warehouse: delete from a table, and then you provide your clause of what you want to delete. So again, you're able to move from data warehouse terminology and syntax directly into this Lakehouse set of syntaxes. Let's do the same with an update. I'm going to start with my not Delta table, my Parquet-based table. I'm going to try and update, change something, set brand equals, and then we'll do the same. We'll do the same then with my Delta table, and we'll see the command it's running be slightly different, and it's succeeding. So it's updated 8 rows. If I look now at the data set from my Delta and my not Delta table, whereas before they were the same, now they're different. So the original data set, that first record has gone. And for my original data set, my 3M brands have been renamed as one brand. I've named them one brand, so they clearly appear as in my list of the top N brands. So you can see how Delta and the Lakehouse principles have enabled us to do some of the seemingly simple, well, it was simple, we've been doing it for many years within a data warehouse. We can now do that within a data lake with much more ease than we previously had to do. And then there are many other features beyond that. Here I've got 2 examples. Firstly, we can see the history of what's happened. So 0 is my original version. You traced it back through time. 0 is my original version. 1 is the having done the delete. and then 2 is having done the update. And it tells you here what operations have happened on those. And then from those different versions, I can go back in time and see what the data look like. So version 0 was my original data set. So here you can see the brand that I deleted and the brand I renamed exists in version 0. I go and look in version 1. The brand that was deleted has now gone, and that 3M still exists, version 2. And so you can step backwards and forwards. You can step backwards in time to see different versions of that data. So some strengths come in to the Delta Lake and the Lakehouse there. If we take that principle a bit further, and this is in preview right now in Databricks, here we have an example where Databricks is starting to introduce constraints. So with constraints, you can now put data quality onto your data. I won't do too much of a demo on that. Getting a little bit more technical now, but not going into too much detail here. There's a whole bunch of capabilities that have been introduced as part of Delta Lake and therefore as part of the Lakehouse. For example, partitioning was already pretty strong when you were working with Parquet files. Now there's the ability to do things like partition skipping when you're reading and querying on that data. Therefore, based upon your where clauses, it will either read from a specific partition or skip a partition. Therefore, it will minimize the number of records and number of reads from the table. We've had a look at time travel. I think Maria referred to earlier schema enforcement, schema drift. So that's pretty strong capability. We can cater for batch as well as streaming data flows. So streaming data flows being data arriving every second or sub-second, being processed through the data lake into reporting, and therefore you get instant visibility of that data. And there are different implementations from each of the different vendors. Here I've got some examples of the Databricks capabilities that I've introduced, while Microsoft is looking at different areas of managing the data in a different way and making sure that we're getting good performance. And it'll be interesting to see where that goes over time. Where will the different vendors take the Lakehouse capabilities and principles? A key aspect of where this is going really is the ability to report out of the data lake. And that's a pretty strong capability for a number of reasons. One, it reduces the number of layers in our architecture. During that, then, it will reduce the data latency. So your data throughput through a data lake into the reporting platform should happen quicker because you haven't got to keep moving the data across different layers. It will therefore reduce then the amount of data duplication. And if you haven't got to move the data across more layers, it should improve the compute costs. In fact, something specifically that certainly Databricks was talking about with its Spark engine when they introduced Delta Lake was to specifically to focus on that compute cost. So much of the data processing has been simplified and automated by the Spark engine in the background. So the Delta processing within the Spark engine has been simplified, therefore reducing potential problems, reducing errors, and optimizing the code management, or optimizing the data management through optimizations in the code. Therefore, as a result, it's processing fewer data records, and that in itself should reduce the compute cost. And therefore, also, if you're taking out some of the potential code management errors, then that again should reduce the compute costs. So processing time, number of layers, data duplication, compute cost, all that adds up to something really valuable. On the flip side, it increases the options. So at the moment, will we settle down to a certain pattern? Maybe. But it increases the options that you've got when you're working out your design patterns. Do you use a Lakehouse or do you use a data warehouse? Do you use a data warehouse, or could you just get away with, is that the right word, a database? You don't need something as grand as a data warehouse. So there are more options now within your landscape, and it gives you more to think about. But I feel like we will settle on the Lakehouse as something that is evolving as really strong going forwards. So how can you get started? The starting principle we normally say is, well, just give it a go. Just start. Define a POC. Define something to prove what you need to do. Used to be the case that we spent a lot more time with our clients helping them to work out 3 and 5 year roadmaps and strategies. Well, the need to strategize is still there. It's still important to understand where you're going, but it's much easier and much more cost effective to just get started, to just test something out, and you can evolve that strategy perhaps as you go. Sure, you need to know where you're going to, but it's much easier and cheaper now just to get started and initiate something. So we offer initiation workshops. We offer workshops that introduce the technologies, introduce how they work, and help you to understand the skills and the capabilities and the design aspects of those technologies. We also offer hands-on introductions to some of the tools. Some of you may well have attended some of our Databricks workshops. Some of you may well have attended some of the Microsoft events that we run to allow you to get hands-on with Synapse, for example. And there are others. We have hands-on sessions for AWS and others. So we offer a number of half-day or full-day sessions to help you to understand and to start planning out what the next steps might be. And when it comes to data science, we offer 1 to 2 day hackathons. Our contact details are on screen. If you have any questions, if you'd like to talk this through in any more detail or help to apply it to your particular scenario, then please feel free to contact us. Thank you.